Right now, somewhere in South Korea, there's a camera watching the Han River.
Yeah, but it's not just, recording video for a human to review later.
Right, exactly. It's
Uh,
an AI system actively analyzing the subtle movements of pedestrians. It's predicting their intent, and if someone lingers too long in a specific zone, it triggers an intervention.
And it's working. It is stopping like 99% of suicide attempts on those bridges.
Wow.
Yeah, and is doing it totally autonomously.
It's just wild because we are not just upgrading our software anymore, you know? We're really handing the physical world over to autonomous systems.
We really are.
And for you listening, navigating this shift is it's about looking past the avalanche of daily press releases. You have to understand the fundamental architectural changes happening beneath the surface.
Yeah, you have to connect the dots.
Exactly. So our mission today for this deep dive is to tear down the headlines from the past 7 days. We're going to expose the connective tissue between four massive shifts. We've got the really messy reality of agentic AI, a fundamental rewrite of how these models perceive reality, the leap into physical sciences, and the geopolitical chess game playing out over silicon chips.
It's been a huge week because the jump from a model that simply answers your questions to an agent that takes independent action on your behalf, that is the defining technical hurdle right now.
Yeah.
We've left the chatbot era entirely. The focus now is on building systems that can execute multi-step workflows across disparate platforms without any human supervision.
And the raw capability is definitely there. I mean, just look at what Baidu released this week with their DuMate agent. A single voice command can trigger the agent to simultaneously book a flight, cross-reference your calendar, and draft an itinerary in a totally separate app.
Yeah, it's impressive.
Or look at Nokia. They are targeting a $6 billion market by deploying autonomous agents into fixed telecom networks. The goal is to have the AI proactively diagnose and resolve broadband issues, physically cutting the number of human repair trucks rolling out to neighborhoods by 50%.
Which is a massive cost saving.
Massive! And ByteDance is leaning so hard into this that they've taken the open source OpenClaw agent framework and spun it into a massive profitable subscription service called ArcClaw. Tech companies are realizing the real money isn't in generating text,
Yeah.
but in monetizing the actions these models can take.
Right. The economic incentives are pushing rapid deployment, but the real-world application is far from seamless. Tencent's CEO, Pony Ma, was incredibly candid during their Q1 earnings call this week.
Oh yeah, what did he say?
He joked that they got on the AI boat and immediately found it was leaking.
That's a great quote.
Yeah. And that leaking boat is a symptom of a very specific underlying mechanical problem with how these agents function. They are highly capable of task execution, but they totally lack strategic reasoning.
Well, and Microsoft actually quantified that exact gap this week. They published a study called Social Reasoning Bench, and the data is pretty jarring.
It really is.
They tested these advanced agents by giving them explicit, overarching goals, like negotiating a better deal for the user. What they found is that the agents enthusiastically execute the individual steps of a task, but they consistently fail to improve the user's actual position.
They just don't optimize for your interest.
Right. It feels like hiring a hyper-efficient assistant who aggressively checks off every single item on your to-do list, but completely misses the context of what you were actually trying to achieve. And they end up, alienating all your clients in the process.
Yeah, exactly. And we have to look at how these models are trained to understand why that happens.
Okay, break that down for us.
So, current large language models are fundamentally built on next token prediction. They are mathematical engines designed to guess the most statistically probable next word or action in a sequence. If you ask an agent to, go to a website and download a file, that is a linear sequence. Next token prediction handles that beautifully.
But strategic reasoning isn't linear.
Exactly. It requires a forward-looking world model. It requires the agent to simulate multiple future scenarios, weigh the secondary consequences of an action, realize a user's ultimate goal is being compromised, and dynamically change tactics.
Which they just can't do yet.
No. Next token prediction simply does not give the model the architectural depth to hold that big picture goal in mind while navigating complex, unpredictable environments.
Well, and if Microsoft's own data proves these models lack a structural world model to protect our interests, rolling them out to manage literal telecom infrastructure or high-stakes e-commerce platforms seems incredibly premature.
Yeah, it's a huge risk.
The South China Morning Post reported major trust issues this week regarding the deployment of agents in industrial sectors. And frankly, I'm with the industrial sectors on this one. If an agent hallucinates while drafting an email, you look a bit foolish. But if an agent hallucinates while proactively rerouting data traffic on a telecom network,
You crash the infrastructure.
exactly, you crash the whole thing.
And that industrial pushback is forcing a pivot. If agents are failing to grasp the big picture, the industry has realized that part of the problem lies in how these models are perceiving the world in the first place.
Right, they're not seeing it clearly.
No, they have essentially been looking at data through a distorted, fragmented lens. Which brings us to the end of what researchers are calling the stitching era.
Okay, so up until this week, if an AI model analyzed a photograph for you, it wasn't actually looking at the image and talking to you with the same digital brain.
Yeah.
It was a Frankenstein setup.
Right, very clunky.
A vision model would process the pixels, translate those pixels into text captions, and then feed that text to a language model. It's like having a translator pass notes between a blindfolded person and a deaf person.
That is a great analogy.
Yeah, they are communicating, but it is incredibly slow, and massive amounts of nuanced context are lost in translation.
And that translation process strips away the raw reality of the data. But SenseTime just released an open-source model called Sensinova U1, and it introduces a native Neo Unify architecture.
Neo Unify.
Yeah, they've completely eliminated the translator. They unified multimodal understanding and generation into a single representation space.
Okay, but what does a single representation space actually mean for the math happening inside the model?
Imagine a massive multidimensional map where related concepts are grouped together as coordinates. In the old stitching method, you had a map for words and a completely separate map for images. To connect them, you had to build a bridge between the two maps. In a single representation space, the raw visual data of an apple and the linguistic text of the word apple are mapped to the exact same physical coordinates on the exact same map.
Oh, wow.
Yeah, the model doesn't translate the image into text. It comprehends the image and the text natively as the same core concept. It sees and speaks simultaneously.
But wait, if everything is matched into one shared map, does that mean the model's hallucinations merge too? Like if a model has a glitch in its text generation and hallucinates a completely fake historical event, could this single representation space cause it to natively generate fake audio or a fake image that perfectly corroborates the lie it just told?
That is definitely the core risk of binding modalities so tightly together. An error in reasoning could theoretically cascade across vision, audio, and text, generating a highly coherent but entirely fabricated output.
That's terrifying.
It is, but the countermechanism, however, is that native multimodality provides stronger internal grounding. Because the text and the visual data share the same mathematical space, they act as cross-checks.
Oh, I see.
Yeah, if the model tries to generate text about an object that contradicts the raw visual data it is simultaneously processing, the architecture creates mathematical friction.
Interesting.
In practice, researchers are finding that this native integration often reduces hallucinations because the model has more context to anchor its outputs.
Okay, and I think the most surprising part of this architectural shift is where it's happening.
Right.
A Tsinghua University spinoff just open-sourced Mini-CPMV 4.6. It uses this native, unstitched, multimodal architecture, but it is only 1.3 billion parameters. It runs locally on a standard consumer-grade RTX 4090 graphics card, yet it matches the performance of models 10 times its size running in massive data centers.
Which is huge. Pushing native multimodal AI out of the cloud and directly onto edge hardware fundamentally alters how we interact with it.
Yeah.
When the model runs entirely on your local machine, the latency drops to near zero. More importantly, it solves the overarching data privacy problem. Your local files, your camera feed, and your microphone data never leave your physical device.
We are decentralizing the perception layer of AI.
Exact.
And once you have models that natively comprehend visual and physical data without clunky translations, and they operate instantly on local hardware, you stop using them just to write code or summarize documents. You start pointing them at physical atoms.
Yes.
And this week, we saw these systems explicitly deployed to solve some of the most complex, chaotic, physical challenges we face.
The transition from digital intelligence to physical intelligence is accelerating so fast. We're seeing foundation models designed entirely for the physical sciences.
Microsoft introduced something called Grid SFM this week. It is a small foundation model specifically trained to predict power flow on the electric grid.
And the grid is so complicated.
arguably the most complex machine humans have ever built. It deals with constant spikes in demand, fluctuating renewable energy inputs, and physical weather constraints.
Right.
Grid SFM predicts grid congestion and reroutes power in milliseconds, saving massive infrastructural costs and preventing blackouts. We are letting an AI actively balance the physical power grid. And Microsoft also rolled out MatterSim, which accelerates simulations for discovering completely new physical materials.
The underlying mechanism in both Grid SFM and MatterSim is pattern recognition at a scale humans literally cannot perceive.
Yeah.
A human operator looking at a power grid sees a few dozen variables. A foundation model analyzes millions of microfluctuations simultaneously, recognizing chaotic patterns and optimizing the flow before a physical bottleneck occurs.
It's superhuman pattern matching, and we are seeing that same synthesis in medicine. Alibaba Health unveiled Hydrogen Ion, which is a medical AI built in partnership with the UK's BMJ Group.
Right.
It instantly synthesizes data from over 70 leading medical journals to assist Chinese doctors with real-time diagnoses.
That's incredible.
But even more mind-bending is the pure hardware leap that happened alongside this. Researchers at the University of Science and Technology of China built the Juzhang 4 programmable photonic quantum computer.
Oh yeah, the quantum leap.
It uses 3,050 photons and achieved a speedup of 10 to the 54th power compared to the world's fastest supercomputers. A 1 followed by 54 zeros.
It's hard to even wrap your head around that number. To understand what a 10 to the 54th speedup means, we have to look at how a photonic quantum computer works.
Please do.
So traditional supercomputers process information sequentially using bits, ones, and zeros. Imagine trying to solve a massive maze by walking down every single path one at a time until you find the exit.
Right, very tedious.
Exactly. A photonic quantum computer uses the quantum states of light particles, or photons, to process information simultaneously. It's the equivalent of flooding the entire maze with water. The water explores every single path at the exact same moment and instantly finds the exit.
Wow. But if a quantum computer is pulling off that kind of simultaneous calculation, does traditional AI just become obsolete?
Not at all. Traditional AI is the software. Quantum is the future engine. The math required to train massive neural networks relies heavily on linear algebra and complex matrix multiplication.
Right.
Right now, we brute force that math using thousands of traditional silicon GPUs. Quantum computers natively excel at multidimensional probability calculations. Once we stabilize quantum hardware, which, to be fair, is still highly fragile, it will compress the training time of a massive AI model from months down to hours or even minutes.
That is unbelievable. And if you have software that can manage national power grids and diagnose patients, and you are building quantum hardware that can train that software instantly, compute is no longer just a tech product.
No, not anymore.
It is the most critical national infrastructure on the planet, and that reality drove the geopolitical maneuvering we saw this week.
Absolutely. The narrative has shifted entirely from commercial competition to sovereign protectionism. National governments are recognizing that advanced compute dictates military logistics, cyber capabilities, and economic dominance.
And we really saw this play out in Beijing. A major summit took place between Donald Trump and Xi Jinping.
Yeah.
And before we get into the details of the summit, we need to be really clear here for our listeners. We are just impartially reporting the facts of this meeting between the two leaders. We aren't taking sides or endorsing any political viewpoints from the left or the right.
Exactly. We're just looking at the realities of the global supply chain as they were reported this week.
Right. Because the stakes are so high, Trump flew in with 17 CEOs, and the guest list notably included NVIDIA CEO Jensen Huang.
Right. That was a big addition.
The entire summit revolved around negotiating global supply chains and the fate of NVIDIA's advanced H200 chip exports, all while trying to establish overarching safety guardrails. You have sovereign leaders trying to draw borders around this technology, sitting across the table from the CEOs whose companies transcend those borders.
And the presence of Jensen Huang really highlights the reality of the bottleneck. The algorithms are largely accessible, but the physical silicon required to run them at scale is highly concentrated.
Very concentrated.
You have a delicate negotiation between the corporate imperative to maintain access to a massive global market and the national security imperative to restrict adversaries from acquiring the compute necessary to train frontier models.
And China isn't waiting around for the export restrictions to settle. Their state council announced plans to accelerate comprehensive legislation for a brand new, overarching AI law.
Yeah, they're moving fast.
But the most revealing detail is how Beijing is starting to treat computing power domestically. They are explicitly casting compute as a national utility, rolling out AI tokens to the mass market.
The token system is fascinating.
Yeah, the pricing structure is designed exactly like mobile data plans. You don't just pay for an app, you buy a monthly allocation of compute tokens to run your own models.
Treating compute like mobile data fundamentally normalizes it for the population. Think about how standardized shipping containers revolutionized global trade by creating a universal physical
Oh,
metric.
that makes sense.
All right, AI tokens do the same thing for digital intelligence. It transforms raw processing power from a niche technical resource into a standardized metered utility, just like electricity or water integrated directly into the daily economy.
But if nations are locking down compute as a sovereign utility, drafting overarching laws to control it, and negotiating export bans on the chips that power it, what happens to the open source movement?
That is the big question.
Like we just talked about mini CPMV running on a local graphics card. Open source thrives on a borderless, unregulated exchange of code. Can that survive when superpowers are treating the underlying technology like weapons-grade uranium?
It is the defining tension of this era. Open source models democratize access. They allow researchers everywhere to inspect the code, find vulnerabilities, and build local solutions.
Right.
But from a sovereign security perspective, releasing the open weights of a highly advanced model is viewed as giving away a strategic advantage. If an open source model can optimize a hospital's triage system, it can also optimize a rival's military supply chain.
Yeah, it's a double-edged sword.
Exactly. The trajectory suggests we will see a bifurcation. Highly regulated, massive frontier models locked behind nationalized cloud APIs, and a thriving but heavily scrutinized ecosystem of smaller, open-source models running on the edge.
Wow.
For you listening, your personal access, whether you can download an unstitched native multimodal agent to your laptop, or if you have to pay a metered toll to a state-regulated cloud provider, hangs entirely on how these guardrails are legislated right now.
We've covered a massive amount of ground today. We started by unpacking the reality of agentic AI models that are incredibly efficient at executing tasks, but mathematically lack the forward-planning architecture to truly protect our strategic interests.
Yeah.
We looked at the end of the stitching era, where native multimodal architectures like NEO Unify finally map visual and text data into a single representation space, fundamentally changing how AI perceives reality.
Which is a huge leap.
Huge. And we saw how this deep physical understanding is being pointed at our most complex infrastructure, predicting power grids and synthesizing materials, while quantum computers prepare to exponentially accelerate the underlying math.
Right.
And finally, we watched the global superpowers sit down to negotiate who ultimately controls the silicon that makes it all possible.
Everything we've discussed points to a single, rapidly accelerating reality. The autonomous systems managing our physical world are evolving far faster than the legal and strategic frameworks meant to guide them.
Which brings us back to Microsoft's finding that these agents consistently fail to optimize for our actual human interests.
Exactly. And this is what we need to think about. If we are handing the keys to the power grid, the telecom networks, and the physical infrastructure of our cities over to autonomous agents,
Yeah.
and their underlying architecture still lacks a reliable understanding of what we ultimately want. What happens when these systems are the ones negotiating with each other across global supply chains? If they don't understand the big picture, where exactly are they driving us?